Today we'll talk with you about operators in Java. What are operators? An operator is a symbol that performs a specific kind of operation on 1, 2, or 3 operands and produce a result. Operators in Java can be categorized based on two criteria. The first criteria, number of operands. There are three types of operators based on number of operands. An operator is called a unary, binary, or ternary operator based on number of operands. If an operator takes one operand, it's called a unary operator. If it takes two operands, it's called a binary operator. If it takes three operands, it's called a ternary operator. And the second criteria, type of operation they perform. An operator is called an arithmetic operator, a relational operator, a logical operator, or a bitwise operator, depending on the kind of operation it performs on its operands. Today we will talk about all operators which we have in Java. Let's start. I'd like to begin with unary arithmetic operators. They are: unary plus operator indicates positive value. By the way, numbers are positive by default. Unary minus operator negates an expression value. Increment operator increments a value by 1. Decrement operator decrements a value by 1. And here examples of these operators. We talked that numbers are positive by default, so in this case plus sign is redundant. But still, this is unary operator. Here is a minus sign. I believe this is clear, and it doesn't require us to dive into the details here. And here you can see increment and decrement operators. Each has two forms, prefix and postfix. What is the difference? Let's take a closer look at this example. With prefix form, the value of operand is incremented and only after that, value of the operand is used for the operations. In this example, for assignment operation. In this case, I variable will be incremented and after that assigned to i3 variable. In the next example, value of operand will be obtained first for use in operation. In this case, i4 variable will be initialized with 11 value, since we incremented I here, and only after that I variable will be incremented from 11 to 12. And here you can see similar example with decrement. In this line, value of the I variable is already 12, because of increment in previous line. Prefix form of decrement decrements value of the operand first, and only after that the value is assigned to i5 variable. That's why i5 variable not 12 but again 11. In this line, 11 is assigned to i6, and only after that decrement operation is performed. That's why value of the I variable will be 10 here. I will share a link with you to this example, and you can run the program to find the console output with all the examples. You can play on your local environment with prefix and postfix form of increment and decrement to understand it better. Now let's discuss arithmetic binary operators. They are: addition, adds values on either side of the operator; subtraction, subtracts right-hand operand from left-hand operand; division, divides left-hand operand by right-hand operand; modulus, divides left-hand operand by right-hand operand and returns remainder; and multiplication, multiplies values on either side of the operator. You can find examples of basic arithmetic operations right here, and console output of the results. Talking about modulus, let's consider the next example. If i9 variable is 5, then remainder of the division by 2 would be 1. Hope it's obvious that in case left-hand operand is less than right-hand operand, the result is always a value of the left-hand operand, like in this example. I believe these operators looks familiar to you from the times when you were in school. And again, here you can find all the examples. All operators mentioned above works with all primitive numeric types. What else you need to know about addition operator? That it is overloaded. Overloaded means that this operator is used to perform more than one function. This operator also concatenates strings. You can't subtract strings, but you can concatenate them like this. In the next lesson about expression type, I will share with you how concatenation of integer and string happened. Let's review assignment operators now. Everything is easy here. Right-hand operand is assigned to the left-hand operand. You can also see here different variations of assignment operators. They all behave similarly, so let's review one example here, assignment with addition. This operator adds right-hand operand to the left-hand operand and assigns the result to the left-hand operand. The same with other assignments operators. Relational operators. These operators compare values on either side of them and decide the relation among them. The result produced by a relational operator is always a Boolean value, true or false. In Java we have the following relational operators. Equals to checks if the values of two operands are equal or not. If yes, then condition becomes true. Not equals to check if the values of two operands are equal or not. If values are not equal, then condition becomes true. Greater than checks if the value of left operand is greater than the value of right operand. If yes, then condition becomes true. Less than check if the value of left operand is less than the value of right operand. If yes, then condition becomes true. Greater than or equals to checks if the value of left-hand operand is greater than or equal to the value of right operand. If yes, then condition becomes true. And less than or equals to checks if the value of left operand is less than or equal to the value of right operand. If yes, then condition becomes true. And here you can find examples with two integers, which are 10 and 20. No surprises here, everything is pretty straightforward. Logical operators. These operators work only with Boolean operands. Usually both operands are a result of some calculations. In real life, you can check the next scenario, for example. If variable of type user is not null and user ID is not empty, then perform some actions. We have such logical operators: logical AND, short circuit AND, logical OR, short circuit OR, logical unary NOT, logical XOR, or exclusive OR. Let's start with logical AND. Logical AND returns true only when both operands are true. We have this example. Let me uncomment this line. Let's pretend here will be some condition which returns false. And here will be next calculations. I will divide 5 by 0 and will use relational operator to check whether the result of this expression is equal to 0. What would I have during this program execution? We will see runtime exception. To be specific, arithmetic exception, because I can't divide by 0. But I want you to focus on the next thing. If the first operand is false, we already know that the result of this whole expression will be false, because as we discussed, AND operator returns true only if two operands are true. Why then Java needs to evaluate result of the second expression if result is clear from the first operand? I'm running the program. Here we have arithmetic exception. That's why it is good practice to use short circuit AND. In case outcome of the expression may be determined only by the first operand, like in this example, when no matter what the second operand is, short circuit AND returns result of the expression and JVM will not even bother to evaluate the right-hand operand. And here are the proofs. Let me comment this line. The similar example but with short circuit AND will not throw the exception. This proves that JVM doesn't evaluate result of the right-hand operand and relies only on the left-hand operand to return the result. Let me run this program again, and you see we don't have any kind of exceptions. The similar situation with OR and short circuit OR operators. OR returns true in case at least one of the operands is true. In case we can get the result of the expression only knowing the first operand, the short circuit OR ignores the right-hand operand. And these examples will prove this statement. In the first one, we'll have arithmetic exception. Even despite the left-hand operand is true, the right-hand expression is also evaluated and arithmetic exception is thrown. In the second example, we will receive true because the first operand is true and right-hand expression is not evaluated. Logical OR operator returns true if at least one operand is true. That's why JVM doesn't care about right-hand operand if the first one is true. You can see how logical unary NOT works in this example. It just turns true to false and false to true. When to use this? The easiest example. String objects have method isEmpty, which return true if strings are empty. But in your program you want to perform some actions with the string only if string is not empty. Taking into account these API limitations, you use logical unary NOT to implement your logic. It will sound like this. In case this string is not empty, then do the following. That's where you need unary NOT operator. Exclusive OR behaves like logical OR with one exception. It returns false if both operands are true. Now let's take a look at bitwise operators. Hope you watched previous lesson about number systems, because to understand how bitwise operators work, you need to have clear understanding of how integers are represented in binary format. In Java we have the following binary operators. Binary AND operator copies a bit to the result if it exists in both operands. Binary OR operator copies a bit if it exists in either operand. Binary XOR operator copies the bit if it's set in one operand but not both. Binary ones complement operator is unary and has the effect of flipping bits. Binary right shift operator, the left operand's value is moved right by the number of bits specified by the right operand. Shift right 0 fill operator. The left operand's value is moved right by the number of bits specified by the right operand, and shifted values are filled up with zeros. I will show you an example why these two consider it to be different. Binary left shift operator. The left operand's value is moved left by the number of bits specified by the right operand. Let's take a look at examples here. To visualize how binary AND operator works, I put in comments here binary representation of 4 and 5. This is 4 in binary format and this is 5. AND is applied to each pair of bits in the number. Let's treat to 1 as true and to 0 as false. True and true will be true. False and false will be false. False and true is false. And this number in decimal format is 4. That's why 4 and 5 equals to 4. Does it make sense now? The similar example with binary OR operator. True or true will be true. False or false will be false. False or true will be true. This number in decimal format will be equal to 5. Feel free to investigate this XOR example by yourself. Bitwise complement operator just flips the bits. What was 1 becomes 0 and vice versa. Let's flip the bits in this number. Bitwise operators work with 32 bits integers, but for the sake of example I put in comments here only last 8 bits. Here is last 8 bits of 1. And after the flipped bits we have -2. Why? Because in Java integers are signed, and the first bit of the integer, the sign bit, determines whether number is positive or negative. If the first bit is 0, then the number is positive. If the first bit is 1, then the number is negative. Here is the binary representation of -2. To make you understand better how negative integers are stored in Java, please consider this example. Here is binary representation of -128. Why? Because 1 multiplied by 2 in the power of 7, because rank of this bit is 7, that will be 128. Taking into account that the first bit is signed bit, this is -128. And here is binary representation of -64. Why? Because -128 plus 1 multiplied by 2 in power of 6 will be -64. You remember how we did calculations in our number systems lesson? We add values of the next bits to each other. Hope this makes more sense now. Let's take a look how bitwise right shift works. And again, to understand how right shift works, let's convert this decimal number to its binary format. 5 in binary format looks like this. And now let's shift all bits to the right. What we will get? We will get 2, because 2 in binary format looks like this. But what is the difference between right shift and unsigned right shift? If we take a look at the same example, we won't see difference. The 5 becomes 2 after shifting by 1 bit to the right. But if we take a look at example with negative number, we will see how right shift and unsigned right shift operators are different. We have minus 128 here. Unsigned right shift for 1 bit gives us this number. And just right shift gives us this number. When we use right shift operator, it keeps signed bit intact. If original number is negative, then it will remain negative, even after right shift, because first or most significant bit never lost. Doesn't matter how many times you shift. On the other hand, unsigned right shift operator doesn't preserve sign of original number and fills the new place with 0. That's why it's known as unsigned right shift operator or simply right shift with 0 fill. Can you see this in binary format? In the first example, we filled new place with 0. In the second example, we leave the first bit unchanged and made shift here. Left shift, the similar example. Bits are moved to the left, and new positions are filled with zeros. 5 in binary format and 10 in binary format looks like this. So after the left shift by 1 bit, we are getting this number, where you will use bit shifts. Operation with bits considered to be faster than regular arithmetic operations. In GDK, sometimes in the source code, you will find that bit shifts are used. Probably you won't use bit shifts in day-to-day activities, but definitely you will see those in the source code. And now you understand how these operators work. It is very convenient to use shift operators for division and multiplication by 2. Shifting bits to the left by 1 bit is equivalent to multiplication by 2. Shifting bits to the right by 1 bit is equivalent to division by 2. You can also use these formulas for faster calculations of bit shifts. In some x number, shifting bits to the left by y bits will be equal to x multiplied by 2 in power of y. The similar example. In some x number, shifting bits to the right by y bits will be equal to x divided by 2 in power of y. I believe right now you know about bit shifts even more than some senior developers. And last but not the least operator for today is ternary operator. This operator works with 3 operands. This is conditional operator which can help us to write if then else statements. Let's have a closer look to how it works. The first expression usually called condition and should return true or false. In case condition is true, then true expression is evaluated. In case condition is false, then false expression is evaluated. In this example, in case 2 is more than 1 and the result of this expression is true, then first expression is evaluated and this string is returned. In case we have expression where 2 is less than 1 and the result of this expression is false, then the second expression is evaluated and this string is returned. Is it clear? And now let's discuss operator precedence from highest to lowest. I know that some companies also have test questions to test precedence of operators. That's why I encourage you to learn these operators. But in real life, nobody would write the code with multiple arithmetic operators, bitwise operators, along with ternary operators in one line. Usually you would use parentheses to make it clear in which sequence operators should work. So I would leave the learning of operator precedence up to you, because in my opinion it doesn't require to go over each of these right now in video lesson. You just need to learn the table which I will share with you in the homework. And now let's review your homework. Remember that optionally I always recommend you to read books, the same things what we discussed just from different point of view, chapters about operators, and also learn operator precedence described in this table.